one?
Yeah, ako ulit.
One way and two way.
Let's play screen na siya.
Okay, so this would be the panel of our slab. Okay, so we'll have our shorter span and longer span. As per the theory, we can consider that this slab is one way. Okay, one way bending ha.
Sir, sabot na ako naman lang.
One way bending.
Hindi ko magagat si Mr.
Okay, if the ratios of atom ng L over S, kailangan
Greater
this is greater than 2. Okay.
2.20 man, sir.
2.0 na lang, sir.
2.0.
Two-way bending.
Ito, no? 2.20.
Yeah, may point.
Ang atom ng L over S is less than or equal to. Okay. Ang question ko. What if ang scenario is square in yung slab?
Two-way.
Tapos, may
May
middle.
intermediate. Para na naman sa mo.
Alam mo?
Low ko ba low na? Totoo ka, sir.
Ang inyong S, ang L. Pero ilang ang ratio sa S over L? Isang L over S. This is equal to ano siya? 1. One way siya, two way. Ay lang din man, supported on both sides lang.
Gatong sir, wala.
Two way or one way rin?
Two-way.
One way, sir.
This is one way bending. Okay, so when we say one way slab, two way slab, ang aton na bending is either one way or two way. Hindi siya dependent no, sa aton natin. Okay, the way mag-behave ang slab natin if this will carry a gravity load. Okay, so for example, this is a two-way slab as per this parameter, no, based sa aton ratios ang longer side over the shorter side. But the way siya mag-behave, no, if butan mo sa load, okay, dali lang na siya mabend. This can, ang iyang parameter is under two-way bending. Okay? O, dali lang na siya mabend, kaya wala ka sa beam on the other side. Okay? Okay. O, so sa diin mo na siya magamit ng parameter. Okay, this is supported okay, at all sides. Okay? So, ano mga common sila? Ang inyong panel is may beams all throughout sa inyong support. If ever ang inyong support is only found sa two sides lang, tapos ang ratio, regardless, no? Kung greater than 2 or less than 2, one-way bending yan lang. Okay? So, anong difference between one-way and two-way distribution versus sa na one-way and two-way bending? Okay, so when we say distribution, this is how we transfer our loads sa atong mga main members such as your beams and girders. Okay, data, the way we distribute our loads is based sa atong na one-way or two-way distribution. So may arang ako discussion, if ever sa inyong analysis, sir, problems or among framing bounded by two-way slab. O paano kami sir mag-distribute? Let's say this is our panel. Ano naman na frame inyong framing system. Tapos two-way ka na, no? One-way na sanapin mo na two-way. Two-way, sir. Tapos, ang critical frame, hindi siya. Okay, this is our critical frame. As per investigation, sir, ang mga slab, two-way tanan. So, paano naman, sir, i-distribute ang loads? Same. Ako niya, pwede ka mo ka-login, two-way distribution. Okay, sa inyong load distribution, may ka mo sa discussion na inyong load distribution is still one-way for your critical frame. But if ever mag-analyze mo sa inyong slab, dapat i-follow nyo din kung anong governing bending niya. Okay, so hindi mo pwede ma-design ang imo nga one-way bending into two-way nga bending. But in terms ng inyong load distribution sa inyong critical frames, okay, regardless if two-way ng inyong panel or one-way panel, you can distribute your loads na one-way. Okay, this can square pala siya. yan ang pinakapos sa tanan, no? Kasi yung pinakapos ng load distribution, this is one-way distribution. But in terms of slab, you must consider the directions of bendings ng inyong one-way panels at two-way panels. Liwat, anong difference ng one-way at two-way distribution? I mean, sa distribution ng bending. The distribution, this is how you distribute ang inyong loadings nag-act sa inyong loading frame. Kaya ang inyo yaman nga bending is based sa ratio sa inyong size kag if pila ang iya nga existing na supports for your slab. In the way siya mag-bend. So dito yan, sa itong slab. Sa inyong methodology for your load distribution, you can opt for one-way distribution para ano siya. Let's say, hindi pa this is your critical frame. Agay yung critical frame. Mas conservative if ever one-way distribution ng ibig lang two-way panel siya. So matabo diba, ang dali ang part 2, nakita niyo ba? Pagduwa mo ni siya i-distribute. Kaya yung mga couple, pagduwa siya i-distribute. I-distribute mo na siya sa shorter framing or sa inyong transverse bend. I-distribute mo siya sa inyong longitudinal bend. Okay? So this is your structural designer's discussion, if ever one-way or two-way distribution. So ang ating slab, depende sa atong support. Okay? So for our one-way slab, as mentioned earlier, as long ang inyong slab is bounded lang at two sides ang inyong support, this is a one-way bending. Kaya ang ating beam is bounded on two sides, so the unit is bend. And if ever two-way slab, bounded at four sides as long ang ratios ang longer span to shorter span is less than or equal to 2. Other type of slabs. This is a one-way slab. Ako dito sa kanan. Pag plus stars ang framing plan, ang girders ninyo na timog two-way slab. Naminod ba? Namutangan nila sa intermediate beam. Para mag one-way. Anong reason na yun? Namutangan sa intermediate beam. Well, let's say, ang inyo yung girder. Girder is 10 meters. Okay? O, dali ang inyo yung girder is around 7 meters. Okay, tamaan siya kalaba para sa inyong slab. Okay, may design siya two-way. Tamaan mo talaga kung movements mo dali sa piyak. Okay, so ginawa ba, nabutangan siya sa inyong intermediate beam para ang inyong clear span with clear slab is take-out lang. Okay, para ma-avoid ninyo ang large movements na ga-act sa inyong slab. Okay? Ang mga possible option or reason na matutang sa intermediate beam. Ano yan ang rason, sir, na 10 meters? Let's say, niyara mo sa function room. For example, classroom, dapat wala sa post test nga, di ba? So, hindi ka pwede ka butang support yan. Okay? Let's say, one-way slab. Second, na hindi siya may common. Okay, this is a flat slab. Okay, ang inyong flat slab, wala ka mo sa beams. So, ka-support sa inyong slab is your column. Okay? Wala ka sa beam. So, iya nga direction ng bending, automatic, no? This is two-way bending. Regardless ng ratio sa inyong longer side at shorter side, basta as long wala ka sa beams, tapos column lang ka-support, this is a two-way, but this is a flat slab. Ang structure sa bacolod, yung flat slab is ang mesa pier. Ang iya kasi walang master, wala sila sang beam, flat slab na tanan. Mas ang problem din, si flat slab, maka-minimize na sang cost. Siyempre wala ka sang beams. Kaso, ang imo nga required thickness is mas damol compared sa usual na slab. Kaya ano yan ang reason na pinang mas damol ang ating flat slab. Paano gawin yung inyong flat slab, do footing lang lang. Ang inyong flat slab, aking column. Pwede mo siya ma-design yung bending. Kaya mo siya gaan sa reinforcement, so kaya mo spacing. But, in terms of shear, mayara ka mo sa punching shear direct. So, pwede niya buuon ng inyong flat slab. Okay? Kung may flat slab, hindi may column, wala ka sa beam, pwede niya gusto ito ng flat slab. Ang malaki isang flat slab design, daan mo lang inyong slab, usually 200 mm, 225 mm, dodalan. That is flat slab, two-way slab siya. Next, we will have also flat slab, pero may ara sa panel sa dalo. Okay? Dumdum mo sa footing nyo. Diba, we all know sa footing, sorry, all pa ang footing, i-go for a maximum shear. But the maximum shear, of course, at the face ng atong support. So, Same madali. So, aton na slab, ang iyang critical shear at support po. In order to mitigate the effect of punching shear, minubra, pinapadamulan kayo, may anak na sa panel. Yan siya ng panel. To increase our shear capacity if mag-design na mo sa atin. That's slab. And last, we will have our waffle slab. May two-way slab na siya. Ang buwan niya, may mga latbay na use in order to resist your bending. Okay? Okay. So, ng mga common, yung mga plus stars ang inyong mga framing system, including your slabs. So far, naka two-way na kamo. Or may one-way na natin. Or yung pivot, mga maging one-way. Ano tanga ng intermediate din mo tayo. Ang plus stars ang din sa column, two-way. Sir, problema, hindi ko magsumas ang two-way. So, natural namin, tama namin, intermediate beam para mag one-way. For our two-way design, we will have three methods. Okay, first is ang direct design method. Second is equivalent frame, and last is ACI moment coefficient method. So under NSCP, we will have both provisions for direct design method and equivalent frame. But for our third provision, this is bago na siya na method. No? Tama siya kapag that is 1970s pa din. Or 60s na method. ACI 19 na talaga eh. 63. Bago na siya. Pero hindi pa siya obsolete ha. O ginagamit pa sa Japan, pero conservative. Okay? So for our ACI movement coefficient, same siya. Okay, sa aton na NSCP coefficients for continuous waves. So aton na principle for our ACI movement coefficient. Okay, di ba ang aton na principle? Our design moment capacity, okay, this should be greater than or equal sa aton na required moment. And for our required moment, okay, di ba commonly, if simply supported, nagamit na sa WLN squared over 8 kung simply supported. So we can simplify this as our MU, okay, o pagwaon ng ato ng coefficient is 1 over 8 WLN squared. Okay, niya actually isang coefficient. Same yung NSCP provisions no, for continuous beam and slab. Diba, for interior, may 1 over 16. Diba, may 1 over 11. Not again,
1 over 14.
1 over 10. Okay, so these are all your coefficients. So we can write our moment as the coefficient required. Okay, this is the coefficient for your bending. Multiplied by the factored uniform load, multiplied by your square sa inyong clear span. Okay, so ang pamangkot is, ano ang coefficient ganito natin? O same pattern for our continuous beams. Okay, ano ang coefficient na ganito tayo in order to compute for our required moment? Okay, so for the following combinations, for our bending.
Isa lang ikaw, group sa nagsana.
Lang.
Hindi na.
Okay, so this is our two-way slab. So our LA, I'm going. The LA is the clear span. Yung clear span, dapat sa duwa ng isang ayan na slide. Clear span. Okay, long. Short. Si LB, this is your clear span, long no side. Clear span ta, same sa itong mga NSCP coefficients, ang aton na direction sa bending is from the face of our support. Okay, so we'll have our LA, LA, LB. Okay, so we'll consider 3 zones. Okay, so we'll have first our edge, no, from the edge strip. Okay, this is your edge strip. Okay, we are considering bending along the side. May edge ta. Tapos we'll have our middle strip. Edge strip. Edge strip. Middle strip. Okay, this is in consideration sa bending along short side. Okay, dili mag-bend ang slab na. Okay, dili bending. O, edge straight, middle straight ka. Edge straight. Okay, dili bending. So, hindi siya middle straight, edge straight nato. This is in a reference on how the movement is distributed all throughout sa aton na short span. Okay, so let's have a figure there. For example, this is our short span. Okay. Di ba ang short span na? So this would be the bending along short span na to. Okay, considering simple span, no? Ang iya ko ng movement distribution, okay, ang maximum is to occur at the middle straight. Okay. So if this is, let's say, WLN squared over 8. Okay, ang maximum is to occur within this middle straight. Pero kung mas lapit ka sa imong edge straight, ang initial na value is the increase up to 1/3 sa inyong maximum movement. Okay, for short, if there is a inyong bending along short span. Okay, kaya, lang sa short span, dali mag-bend ang slab. Okay, ang moment is greatly reduced after sa inyong edge straight. Okay, so ang ating basis ng design is always at the middle straight. Regardless, no, if ga-reduce siya along your edge straight. Okay? So this is bending along short side. Same ang apply if ever sa ating long span. Okay? So ang LB, this is our longer span. Okay? Iwan kasi LB is clear span. Kasi ma-confuse yung figure. Is dapat natin dash line, clear span siya. So if ever bending is a long span, okay, so dapat dali siya mag-bend, no? Ang bending ta is parallel sa ating long span. So we will consider ang length, LB. Okay, same na dali. This is our bending, diin ma-occur ang ating movements. Ang maximum within this zone. Ang ating middle straight. Okay. Our reinforcement for the positive side, the remove force on middle straight, then this is greatly reduced going to your edge straight. Okay? This is in relation sa ating positive movement. Kaya anong iyang emphasis in it? So for our positive movement, since they are occurring at both sides, we will have main reinforcement direct sa middle straight natin. Okay, so this reinforcement will resist the bending along this direction. Okay, sa liwatan, ang reinforcement na parallel sa ating short side, liwatan, the reinforcement that is parallel to the short side is the reinforcement for the short side na bending. Okay, syempre pag dali nyo mag-bend, sa mabuling ang inyong reinforcement. On the other side, okay, sa inyong parallel to long span na bending, dali mag-bend. So you need to put reinforcement along long side. Okay, so we will have our positive movement along long side. This is our reinforcement for the bending along long span. So duwa ka bilog ang aton na reinforcement. Okay, we will have along short side at along long side. Okay. Pero ang aton na beam, ang aton na idealize na slab, this is a continuous two-way slab. Okay, same sa aton na one-way, no, sa LCP 15, ang aton na two-way slab is continuous all throughout sa aton na line. Okay, di ba for our one-way, sa inyo assignment, may assignment. Nalipat ko lang. Nalipat ka lang ko lang. Nalipat na po. Ay, message. Let's say, these are all one-way patterns. Okay, so mag-create ka sa aton na reinforcement. Okay, ibang bending na may consider along, di ba, the green side. So we will take a 1 meter strip. Okay, agad na 1 meter strip. Kaya ato ka slab, i-atsura, ito pa mo nito. This is your beam. Slab, beam. Slab. This is a continuous na one-way slab. 1 meter straight. Kasi syempre, yung bending is along the short side. But for our two-way slab, this is a continuous slab at both directions. So how can we determine the values ng ating movement based sa ating mga continuous slab? Okay, so we have the following vision. Okay, so we consider bending along short span. Okay, so you consider kahalan is our shorter na clear span. Okay, that is your LA. Okay, this is the design for middle strip. So for our positive movement, we will separate our dead load and light load. Okay, here, out kaliwatan, ang ating slab will only carry your dead load and light load. Wala siyang resist na wind load and seismic load. Unless, specify ninyo, ang inyong slab will act as a diaphragm. Okay, so what do we mean by diaphragm? Ang wa niya, inyong slab, if ever may lateral load, mabulig siya resist, i-main mo siya as a lateral resisting frame system. Okay, so for your design assumptions, okay, sa inyong computation for your project study, ang slab will only resist vertical loads. As long as way ang building sa slab, wala resist. Okay, wala siya ka-bend due to lateral. So mainly, ang aton na loadings is composed of dead load and light loads. Okay, for slab. Okay, so no need mag-MDM sa slab ha. Kasi syempre, ang inyong slab is not a part of your main framing system. Okay, ang iya lang dyan na-carry is ang inyong gravity load na due to dead, due to light. That transfer niyo going to your beam. Okay, so for our positive movement and plane, okay, so si pa-consider, si light, because ang ilang mga coefficient will have this positive CA, okay, this is the positive movement coefficient along short span for them. Okay, si positive CA light, this is the positive movement coefficient along short span due to light load. And for our negative movement, okay, pwede na makombine both dead and light load. Okay, kapag ko sila yan, visualize na protected drawing, di ba? Para mas klaro. Siyempre sa inyo nga methodology, kapag ito sa wordings niyo, sumambala ka mga along short span tapos equation. So it is our two-way slab. Okay, so we have our longer clear span and shorter na clear span. Okay, so if ever the bending, okay, kita, bending along short span. Okay, so for our mid span, we need a reinforcement na positive ay ito, na parallel sa ating short span. Okay, if ever the bending is along short span, we need to put reinforcement there. So this is the reinforcement along short span. Okay, okay. Dito siya ma-bend, siyempre may moment, hindi nga positive sa tunga. So this is your bottom bars. Then, if ever may bending ka mo along long span, okay, dili ma-bend na natin na slab. We need to put reinforcement sa bottom bars along long span. Okay. Dira lang sa asta sa ating middle strip. But for common practice, ang ila rin obra, alternate, no? So, ang inyong bars are extended. Okay, alternate siya, in-extend. Okay, up to your support sa bottom bars. Okay, extend, tapos ang isa cut, nag-extend ang isa cut. Tapos last, ma-extend siya. Same with your along short span. Alternate. Hinihingi mo siya continuous. Sino nakakita two-way slab sa side? Paano na-plaster? Okay, ang bottom bars is placed, no? Okay, this is the spacing required, pero every other bottom bars ninyo, ina-continue siya going to your support. Okay, so we now have your bottom bars. Dali na. Ang aton na actual, okay, this is in terms of bending moment. This is your LA. Okay, amunin nyo nga LA over 4, edge strip. This is LA over 4. Okay, anong significance ang inyo nga mga middle strip, edge strip? Okay, so commonly, ang inyo nga edge strip, okay, dali ka or ang negative moment. So if this is our bending diagram, okay, may negative moments dali. Tapos, mag-zero siya about this, L over 4. Tapos, positive moment, manaog dali. Okay. So, we'll have a negative moment along short span. This is your MA. Okay? May negative MA dire. This is our positive MA. This is the moment along short span. Okay? At paano magsuma sa MA? Ara sa atong equation. If you want ang moment MA, this is the moment along short span. Okay? So this is defined as your coefficient for your short span multiplied by your uniform load times ang ating mass square of our clear span along short span. Same dire sa ating long span. Wait that way. Wala na. Okay. Same will apply sa bending ka along long span. This is your positive moment along long span. This is your negative moment along. Okay. So that is two-way bending. Okay, so we have considered our main reinforcements only for our positive moment. O, paano plaster in terms of negative moment? Siyempre, you will have two sides, diba dali? Okay, so along your left side, may negative moment naman dali, ma-plaster na sa atong na top bars. Okay, so top bars are placed all throughout that. So may top bars na dali. Okay, so these are your main reinforcement, okay, for the negative moment along short span. Okay, may top bars naman dire. Top bars na lang. Dira lang siya stack. Eh, syempre, hindi naman negative moment, dali naman na stack. Okay, no need siya i-extend. Baka sa mid-span, kaya hindi naman negative moment is up to L over 4 only.
Putod na siya, sir.
Putod na siya. O, anong tsura sa section? Bugangan sa pag So, this would be your section. Ang section nyo, E41. May bottom bars ka mo, tapos ariin yung top bars.
Putod, sorry.
Okay. Same din. So along your long span na bending, di ba dali siya mabend? Okay, this is your moment diagram for your long span. Okay, you need to provide a top bars for the negative moment along this edge strip. So may top bars na dali. Top bars. Tapos may top bars. Ano siyang figure? Folding bed. Folding bed. Bottom bars. Tapos nga mo sa bars. Okay. Sa inyong midspan or middle strip, you will have reinforcements at along both sides. Okay, so you don't need to design for your temperature reinforcement. If ever mag-expand, okay, or mag-contract ang inyong slab, you will have your main bars along this direction to resist ang shrinkage or expansion. Same na rin. Okay, if ang inyong slab will expand or will contract at this direction, okay, you will have your main reinforcement along midspan to resist the expansion ka contraction. Ang problem galing, what area sa midspan? Di ba may main bars kung madali? This is the main bar for the bending along short span. Along long span. Okay, these are your main bars for the bending along short span. Ang problem is ang ara sa aton nga support. Okay? Eh, di ba sa aton nga support, why nag-overlap ang aton na main bars for our short span kag long span? So, nung tendency dali. So, if ever ang inyong slab will expand or will contract along this edge strip, okay, same dali, mag-expand or mag-contract, wala ka masang temperature bars. Okay, so pwede siya, if mag-expand siya along this direction, o wala ka sang kabilyada nga magtugong siya nga mag-expand or mag-contract. Okay, that's why we need to decide the temperature reinforcement at your edge strip or at your supports. Okay, so madugang naman natin. So we will have our temperature reinforcement for our edge strip. Okay, ako na i-explain ako ano lang siya. Okay, so
Maganda sample, sir.
May sample.
Actual.
This is your temperature bars ng luwa. Temperature bars. Even sa actual, good line siya i-visualize. O once na plus ng kabilyada, uy, yung kabilyada. Wait na ako ba tayo ang change sa side. Okay, once mag-cluster na ng kabilyada, good line pang itaon. Din ang main bar, din ang transverse bar. Okay, so this would be our concept. Okay, along sa ating edge strip, we need to provide temperature reinforcement because we don't have transverse reinforcement along your edge strip. Okay, so ang green, these are your main bars for your bending along short span at along long span. Ang red ninyo, these are your main bars for the negative movement along short span at along long span. Si color blue, this is your temperature bars at your edge strip. Na-emphasize siya. Pila ka bilog ang inyo nga i-design for each panel. O, diba? Duwa ka bilog sa positive movement. So, duwa ka spacing. Then, you'll have also a negative movement along long span. So, tatlo na. Okay? Main reinforcement for the negative movement along short span, apat na. Ikalima ang inyo nga temperature bars. So, 5 ka designs for each panel. Okay, ang question, going back, paano sir mag-identify sa amon na coefficient? This is the point of the ACI moment coefficient method. Okay, so principle sa atin ng ACI moment coefficient, this will be based on what type of support. Okay, ang ginasupport sa atin, ang nasupport sa mga panels. So we'll have 9 types of panels. Okay, so this will be our legend. If ever may hatch ka, that is a discontinuous edge, so outermost part ng inyong framing. Open siya, that is a continuous edge. Same na rin. Aring nga pa, sa inyong slab, ang aring nga side is discontinuous, ang aring nga side is continuous. Kaya continue pa siya sa inyong adjacent panel. Okay. First type of two-way panel. So we'll have our rear panel, or this is case 1. Second, we'll have one short edge discontinuous but all sides are continuous. Third, ang inyo naman na long edge ang discontinuous. Fourth, mga corner panels natin, two adjacent edges ang discontinuous. Fifth, two short edges discontinuous. Okay? So for like mga best examples in two short edges discontinuous. So nakaspan ko lang siya bagutin yung dual way. I mean dual way. Tayo.
Suspended nga naguro sa.
Okay, 6, 2 long edges discontinuous. Okay, 7, 3 edges discontinuous. Let's say may harap ako sa exterior slab, tapos may harap ako sa beams, palibot sa iya, may terasa ka mo. Okay, 7. Okay, 8. Sulit naman siya, pero ang inyong short edge is only at one side na siya. Then last, for our baseline, all edges are discontinuous. Okay? So that would be our support conditions. Okay, we need to identify each panel if anong iya support condition. Okay, ano siya case. And from this point forward, ang atom na coefficient or ang si ACI movement coefficient, ang iya assumption okay, ang ating continuous beam, unlike ang LSCP coefficient, okay, ang iya assumption, tanang supports are pin and roller or a continuous na slab. Okay? Unlike NSCP, i-assumption tanan are fixed and dead. Okay, so anong significance na rin? So if ever ang inyong slab has a discontinuous edge, okay, this is a discontinuous edge. Discontinuous. Okay? Wala asang negative movement rin. Okay, diin lang ang may negative movement. O, try tayo draw ang iya movement dito. Di ba ka-try naman sa theory ko, continuous beam? I mean, di ka mag-drawing, shear moment diagram. Iwat amo ni assumption ni ACI movement coefficient. This is a continuous beam wherein ang iya support is simple lang kanan, either pin or roller. Tapos, ang iyang moment diagram is at your discontinuous edge, zero ang moment, tapos ma-positive, ma-negative. Negative, positive. Zero at your discontinuous edge. Okay, so for short, ang aton ng mga negative movements at our interior span, hindi aton siya value except for our discontinuous edge. Okay, so later on for our design, okay, ang basis kasi for our reinforcement na rin. Ang question, sir, di ba mention mo at the discontinuous edge, zero movement, and the assumption is either pin or roller. Let's take for example, this is a discontinuous edge, okay, for your short span. Okay, sir, since zero ang moment na rin, okay, ang moment is zero, do we need to put reinforcements, okay, at your zero moment? Yes, we need to put reinforcements at ang itong taes ang minimum area of steel reinforcement or your ASMIN. Okay, what okay, paano yung sa later? Ang atong na discontinuous edge, zero ang iyang assumption na rin, okay, sa movement. But, we need to put reinforcement na rin using our AS minimum or the minimum area of your reinforcements for your slab. Okay? As principle. So we'll have the following tables. May question din siya makitaan. May obsolete na rin iyang file. So mostly ng mga books ilalubra. Tinatry nila revive. Kaya mga figures na ACI. Kasi naman na 1963 lang siya ng ACI. So very new nung pinalaki po eh.
60.
60 years na. 60 years. 2020. 60 years sa ACI movement condition.
Favorite day?
So we'll have our table 1. Okay, so these are your negative movement coefficients. Okay, or for sure this is your negative CA or negative CB. That is CA negative, CB negative. So first na parameter, we compute first for our ratio sa shorter side over sa longer side. Alam mo kasi LA shorter, LA is the longer side. Okay, ilan na rin natin ang ratio. Then, after determining sa ratio, we will identify if anong ating support condition. Is it case 1, case 2, case 3, or case 9? If ever ratio is 1, this would be our coefficient for case 1, so 0.045 for bending along short side, CA. Okay, or 0.045 also for bending along long side for CB. Okay, kung may notice ka mo, ang ratio is equal to 1 or almost square ang ating panel, same ang ila ka coefficient. Siyempre, same ang ila ka property in terms of bending. Pero if ka-differ na in yung ratio sa shorter side over their longer side, ka-differ naman also in yung coefficient along short side, coefficient along long side. Okay, depende sa inyong support base. Last, try to observe ang case type. Diba these are all moment coefficients for negative moment. Okay? Wala value si case type. Sa negative value. May tanan sila discontinuous. So for short, pin. Wala ka sa moment for case type. Okay? Improve na lang ang balat kanina na si ACI moment coefficient. Okay, ang tanan yung discontinuous edge, 0 ang ilang negative moment. Okay? So this would be our negative moment coefficients. Second table. Okay, so these are our positive moment coefficients for that load. Okay? And these are our positive live load no, sa moment coefficient. Question sir, natin si positive load kasi live load. Okay, same lang di ba na effect? Si ACI moment coefficient, consider yan lang inyong live load patterns. In order to produce the largest positive moment possible, you consider natin in a place live load. Okay, that's why for your two-way slab, you don't need to consider live load patterns. Okay, sa values ang inyong coefficient for your live load, you consider yan natin. Ako naman na inay na coefficient ito lang. Okay, for case 1 with ratio sa shorter side o longer side na 1, okay, this is 0.027. But for our dead load, that is 0.018. Okay, consider ng live load placement na to produce the maximum moment for this span. Okay, even if this is continuous. That's why kasi proxy live load for your positive moment. Last, last sir. These are your coefficients for shear. Okay. So 4 tables. So far, walang kwantitan ang terminal package yan halos no ginagawa sa mga books is kina-revive nila ang old package. Siyempre 1963 na mga expect ang daan, di ba? Typewriter, basta ako hindi lang mga division. Okay, example number 1. Tao lang. Okay. May table may provide.
Sir, tabagan mo kami, sir. Nice
So we
one.
have our page system. Tao lang yellow.
Hindi, may sir.
Bench.
Pwede lang, sir.
Snake racer.
Okay lang. Okay, so for our framing system, okay, all beams, okay, ang parallel delay, these are all B1. B1 sa B1.
One piece burger steak, sir.
Okay, this is B2.
May Shanghai na, sir.
So design the reinforcements for this slab shown. Okay, so we'll use that. Get some point. I'm trying to say is 21 MPa. For 20 MPa. At YP, we will have also 40 MPa. Loadings 1.8. our point A.
Wala na lang, sir.
Okay, so we'll have our payment system very clear. Okay, sorry, given that. So we'll use a F prime C or specified complex strand of 21 MPa. Then for our main bars and transverse bars, we'll use another 420 MPa. Okay, so we'll have our superimposed dead load na 1.8 kPa and live load pressure of 4.8 kPa. So we won't consider live load reduction there. And we will have our beam. Okay, may beam 1 tama 300 by 500 mm. Tapos si beam 2 is 250 by 400 mm. Okay, from our figure, okay, all dimensions are measured from the center ng ating beam. Siyempre, yung mga frame system, yung floor plan, okay, all locations ng inyong columns are measured from your center sa column. Okay, so ating mapalang A. Okay, so for our first part, we need to determine pila ang reinforcements ng our spacing for our panel A. Okay, so we have our B1 along 7.2 meters, then ang B2 is along 6 meters. So for this problem, given ang thickness. Okay, we won't discuss how to compute for the minimum thickness, but you can use the NSCP provision for the minimum thickness. Medyo lawig siya. Okay, in-exclude ko lang. Okay, hindi siya na 175 mm na consider hindi ang effects of tension. Okay, so for our solution, let's consider panelation. Maliwatan. So for your design, okay, you need to compute bilang minimum thickness, but we won't discuss on how to compute for the minimum thickness. Ilawig siya na part. Okay, so, siguro ilog siya na solution for thickness lang. Pero ito lokong mode, anong magamit din for thickness? Diba, anong mode?
Ano, sir? Chapter 4, sir.
For you to compute the minimum thickness, okay, so we will use table 408.3.1.2. These are all the provisions for the minimum thickness, and ang inhatag ng minimum thickness is already compliant with that code provision. Okay? But si 177N compliant din sa minimum thickness na ito. Okay, so let's compute first ang inyong LA kag LB. Okay, computing for LA. LA is a clear span along short side, so we'll have one center spacing of 6 meters.
Ay, gusto mo
6 meters less sa natin nga anong ka-bound between 6 meters and is hindi kita on. Iba niya.
Lumuya na ako mo kasi man. Wala pa tapos lang.
Anong yung less as per hour LA? B1 or B2? Para makuha ang clear spacing along short span.
B2, sir.
B1 ang
Two-piece burger steak.
Yes, B1. 0.3. And then this is 5.7 LB. It is long span. 7.2. Okay, that is bounded by the wall.
Joke lang. Tangna. Sa prestige. Good, sir.
300 with kabilang LD,
Harap
6
din.
point,
System.
25.
Section. Okay.
Okay?
Section.
Then let's compute your
Subsection.
ratio F. Okay?
Equation.
Si L is the ratio
Equation
sa
table.
a shorter side over sa aton na longer side. Okay, LA is 5.7 over 6.95. Pila niya? 0.82. Okay? And for our panel A, okay, that is bounded no, sa corner natin. Okay, for panel A. So, ano siya ang support position? Panel A natin. Between these 9. Okay? So, for panel A, ang support position. Ano na, ang creating nuts? Ang si panel A, ang sa corner.
Dua ko.
Ano na siya ang support position?
4,
Ace,
sir.
ano?
4.
Ace.
Boss line.
4, sir.
Okay. So that is case 4.
0, sir.
So, 2 adjacent edges ang discontinuous.
Sino na?
Okay, so let's solve first ang ating coefficient.
Di mo na ba kayo? Sino nga ito?
Lipat na. Saan mo naman pwede?
Or bending along okay, ang process for our two-way slab, same ito nga one-way slab, we will assume a 1 meter straight. Okay, so if this is our figure, okay, makuha natin 1 meter straight for our long span, makuha natin 1 meter straight for our short span. Okay, so let's compute sa ating self weight. Okay, so this is the area of cross-section multiplied by our unit weight of concrete. Since we have considered a 1 meter strip, okay, so area is equal to 1 times sa thickness is 0.175. Okay, unit weight of concrete, we will use 23.5. Ilang ating self-weight?
Okay. 4.1125. Okay, solving for our total dead load. Okay, so we have our self-weight for our superimposed dead load plus self-weight. So since we are using a 1 meter strip, so for our superimposed dead load, okay, ang atong typical width is 1 meter lang. Okay? Superimposed is 1.8. Yes, 4.1125. Ilang atong dead load? 5.9125.
5.9125. For our live load, it is 4.8 times the typical width na 1. Okay. So let's consider first bending along short span. Okay, and we will compute for the negative moment. Take note ang atong nga negative moment will be composed of two sides. Okay, depende sa inyong support condition. Okay, so you will have your discontinuous edge. Okay, you will have also your continuous edge. Depende sa inyong support case. Okay, so since we will have case 4, okay, so mayroon na sa discontinuous edge along your short side. We will have also discontinuous edge along your long side. So duwa ka bilog. Okay, so for our negative movement, we can consider first ang continuous side. Let's compute for our negative CA. Note na, coefficient for the negative movement along short span. Okay, and we will consider the continuous side. Okay, ang aton na M. Okay, ang M na is lalamit. 0.82.
82.
So that is found in 8.85 tag, 2.8. So we can distinguish your interpolation. Okay, so for our case score, zoom mo na lang. Kita mo lang.
Oo, sir.
So we will be computing for our coefficient along the base short span. Okay, CA negative. Okay, for case 4, so that is 0.066 tag, 0.071. Sakto, di ba? Nakatip mo.
Given no table.
Oh, yeah, nag-table. Ilang aton na negative CA? 0.069. Okay, next. Negative movement. Discontinuous. Iwan external panel na mula sa discontinuous side. So no need to compute for discontinuous side. So ang ating nga negative CA,
0, sir.
third. Short span pa lang, no? Positive tayo. Ilot na bending along short span na na yan.
Same naman sa coefficient, di ba 34 years na continuous?
So for positive movement, this is for dead and leg load. Okay, solving for the positive coefficient for bending along short side. Okay, that is for dead load. So next table that.
Pero ito ka rin with one ka rin.
One A coefficient for that load, A positive movement in two-way slab. Okay, so that is bounded between 0.85 to 0.3. CA yan, first span. Okay, so for case 4, we will use 0.036 and 0.039. But this is for the dead load. So 0.036 less sa atin na 0.039. Sila ang positive coefficient for bending along short span okay, due to that load.
0.0378.
0.0378. Okay, so for our live load, .043,
Oh, sir, 0.043.
negative
0.048.
Bilang atong efficient for live load for bending along short span.
0.046.
So, 0.0.
0.46.
Take note that this is okay. Complete na itong coefficients, okay, for bending along short span. Okay, next, for bending along long span.
Ayun ko na.
Okay, so for bending along long span, okay, so let's consider a coefficient CB. Negative moment naman tayo. Okay, so table 1, so these are all negative moment coefficients for two-way slab. Okay, between 0.8 to 0.85 for these four natin. Okay, so we consider, ang yan, CB negative.
Oh, sir.
Okay, so CB negative. Okay, score 0.13 for that. 0.0. Ilan pa mas CB negative?
0.031, sir.
0.031.
31.
Okay, so for our negative moment along this continuous side, okay, this is equal to 0. Last, okay, for our positive moment, okay, table 2. Okay, table 2 are coefficients for that load for positive moment. Okay, so ang ratio is ang short side over the long side is 0.82, so this is counted which is 2 rows. And this is for base score. We will use our dead load. CB, dead load, CB, dead load. Okay, 0.019. This is 0.016.
Ilan na CB for that?
0.017.
0.0172. Okay. Last for our light load, so you will use table 3. Table 3, coefficient for movement coefficient for light load. Okay. So, ang yan position ay between ratio na 0.85 to 0.8. And we will determine our coefficient for bending for long span and CERCDN430. For case 4, that is 0.023 at 0.020. Ilan?
0.01.
0.
0.0212.
Okay. So we are now done with the coefficients for bending along short span kag long span natin. Okay, so this is your CA coefficient for bending along short span. Okay, CB is the coefficient for bending along long span. Okay, so we have categorized first in terms of negative moment. Either way, for our negative moment, we can combine. A2 nga ng inyong dead load to light load. That's why for our negative moment, wala na sa dead tag light. Okay? So for our CA negative, that is 0.069 for a continuous side. Okay? So for our along long span is 0.031. May na-observe mo, anong difference between bending? Hindi yan ang mas dako. Short span or long span?
Short.
Mas dakong short, di ba? Okay, simple. So, kita, positive movement due to dead load. Okay, along short span, ang atong coefficient is 0.0378. Okay, sa atong long span, 0.0172. So, anong iya significant, sir, na aming mas dako si short span compared kay long span? Ay mas dako siya movement. Di ba mas laba, mas slender, dapat mas dako, di ba? So take note ang inyong moment is the internal reaction, okay, not the bending produced. Okay? So since ang inyong short span is mas stiff siya compared sa inyong long span, syempre mas dako ang iyang moment ay produce to resist your internal loadings. Okay? So that is opposite no compared sa long span natin. And since from our coefficients, okay, we have proven that ang atong bending along short span, okay, that is greater than compared sa long span natin. Okay, so dapat ang atong main barsa, okay, what? Sa main barsa, okay, ang pinaka-outermost na reinforcement, dapat this is the reinforcement along your short span. So the first bar there. Okay. This is the reinforcement along short span. Okay, since mas dako ang iyang moment, dapat malocate siya sa pinaka-outermost portion of your member. Okay, in order to produce the largest moment arm possible. And since ang ating long span or bending along long span is found, no? Okay, na mas mabuo siya compared to short span. So ang ating long span, itong natin din. Okay, so these are your reinforcement for your long span. So babaw siya. Amo na nga kung mag-practice kung sa side sa ulihin, that is a common term na mag-plaster some bars, short, long, short. Okay, short span first, long span, tapos sa top bars niyo, long span, tapos short span. So i-extend ko diyan. Let's say you will have your reinforcement, okay, sa support. So syempre, inyong outermost, okay, ang pinakalapit, this is your negative moment reinforcement or support reinforcement for your short span. Tapos, may aga ka mo sa long span. Aking long span. Long span. Short, long, short. Even sa footings.
Short, long.
Okay, short, long, short.
Sumata? Mata?
Hindi ko sumama.
I mean, masuma na sa reinforcement. Hindi ko lang na pa-erase. Reinforcement is 9 ta.
28, sir. 28.
Sumata reinforcements and we will place them sa atong nakanali. Hindi mo suko na. Ito na mag-i-erase. Hard work and hard planning. Okay, so for our design of reinforcements, okay, we will consider tanano. Okay, we will consider a 1 meter strip all throughout. Okay, so our design section, okay, ang atong na total width should be 1,000 mm. Okay, so before we start, okay, may mga common values ta regardless if bending along short and along long span. Okay, so we will have our AS min. So si AS min nga ne. For our AS min, we will use formation sa atong na one way slab.
Ano, sir?
So one way slab, I mean two-way slab. Okay? So for two-way slab, we will use chapter 408. 408 is two-way, 407 is one-way, 409 is beam,
Wow.
410 is columns, no?
Wow.
411 is walls.
Wow.
May manok sa pula.
Takto, takto.
Sakto. AS mean for non-pre-stress na two-way slab. Okay, same na din sila sa aton ano, one-way slab. Okay, so since ang aton na FY or the atomic yield strength for our main reinforcement, raised to na. Okay, so that is 420. Okay, so we will select the paper between AS mean.
Passport.
Okay, so we'll have 0.0018 420 over F1
Then, pareho na. Hindi ah.
multiplied by 80. Second is 0.0014 Okay, so since we have considered a 1 meter strip, the sign of reinforcements. Okay, now, si short side bending along. Yung question ko, anong difference between along at about?
Ano mo naman ito?
Ano?
Ang alam sir.
Ang along, parallel. Ang about, perpendicular.
Di ba sa biaxial bending, doon ka mo rin, about at along. Oh, so when we say bending about x-axis, so sa bending, kung ano yung bending is bending
Ano?
about.
Ah,
About or along?
About, sir.
x-axis, saka. Okay. Or other term, this is, ano na yun? Bending
along
along
Y.
y-axis. Okay. So when we are referring bending along, okay, so if this is our short span, this is this is bending along, okay, parallel sa inyong short span. Okay, so bending along short span. Okay, mas ma-confuse ka muna between about and along. Okay, so when we say along,
Laba.
bending along. Okay, that is parallel to your short span. Okay, kumita na yun.
Ay! Ganun pala bilisan.
Okay, where ang ato na 8 is equal to, yes, na-erase ko naman sa 175 mm. How to compute for our D? Okay, so for this problem, ito ba naman ba? Main bar. Okay, so we'll use only 10 mm diameter for our 10 bar. Okay, we'll use also 10 mm. Okay, same grade na. Diba? This is bending along short span. Ang siliwan ng ating na short span must be located sa outermost natong na reinforcement. Okay, so ang atong na D is equal to H minus our clear cover minus bar diameter over 2. Okay, so we'll consider an interior span. Okay, so this is 175. Okay, so for interior span, ito ang interior cover for slabs. This is 20. Okay, minus 10 over 2. O, bilang dita? Yes, correct. Bilang to? 150. 50. Okay, for bending along short span. So, bound namin. 0.0018. Okay, times 420. Over 420. Take note that P is equal to 1,000 mm because we will consider a 1 meter strip.
BWD.
1,000 times 175. Ilan na siya?
Ilang sir?
315.
315 mm squared. Per mm, di ba? Next, 0.0014 1,000. Ilan eh?
245.
245 sir. 245.
245. Ay, dito ta. Nag-iis min.
Babaw.
Ang babagor, sir?
315 yun sir.
Ay, pakita ko lang mga dapat ang maximum pilikod. Ay, kasi magsala lang ang minun na. Use. Okay. So therefore, our AS min,
Pinag-test niya.
pinatest na lang kami sa bala. That is 350. Okay. Bending along short span.
So let's consider first bottom bars. Okay, bottom bars along short span. So therefore, this is your main reinforcement for the positive moment na po. Okay, so let's consider positive MU. Okay, about A, MUA. Factored moment or the required moment for the positive bending moment na to along short span. So this is equal to paano siya sumabot? Okay, oh. Si Paka, la incident, la NC, live load. So this is 1.2 times sa aton nga positive CA for dead times LA squared. Okay, plus 1.6 positive CA for live load. Okay, LB squared. 1.2 CA dead natin, that is 0.0378 along short span.
Wait.
Ang LA na is 5.7. Ay, sorry. Plus 1.6 positive CA line.
Wala yung game daw.
Okay. Ilan ko lang kung nakamati. 0.0378. Uniform dead. Okay, for every 1 meter stay pa, the uniform dead is ilan na?
5.9.
5.9.
9125.
125.
2.5.
ALA is 5.7. Check na. Plus 1.6. ALA sila 0.046.
0.046.
Or 6. Ilang uniform light? 4.8. LD nila.
6.95.
Ang 5 point?
6.7. 6.7.
6.95. Pila ang required moment or
Ay, wait.
backward moment along short span. Check ko na eh.
5.7.
5.7.
Insunod lang naman yung mga example, sir.
Pakita niyo anong dapat ito. Ganito.
20.192.
20.192.
192.
Kompleto, saan lang ilang? 191.
1915.
1915.
9279.
9279. Or this is equal to 20, 191, 592.79 Newton.
Stop it, sir.
Okay, ang principle na same siya po na. So dapat ang aton na design moment capacity, this should be greater than or equal sa itong view. So we can have two methods. Okay, so we can use the equilibrium equation natin. Or, para mas lasing, para kapusanan, MRN natin.
Oh, naara na naman.
May lang ang pixel ba?
Hindi na yun, sir.
MU over PUD squared. Okay, so we indicate ang factor na 0.9.
Bakit? Ngayon pala.
B is 150. Ilan si Arlen? Yes, sir. Ilan ako?
0.997.
Ilan? 0.9.
997. 115 na. 1156. 933.
Din tayo store si Arlen.
Sa 8.
Store sa F. Okay, F sounds like R.
Labing lapit ba?
Bakit ah?
So let's solve for your raw.
Dito eh.
At prime C over Y.
Sir, hindi ko nakasulo. Kaya mo na, sir.
Oh, i-condition mo ang equilibrium equation. Pwede
Ako
na
niyo?
24.
Uy, kaya ko ito.
Ano ba si Boy? Sorry, baka ko. May ikaw mo na ako.
Ilang R yan eh. Store sa F.
Sir, I think kaya mo na.
2R na lang.
Ilang si Rom?
Lang. 45.
Over 420.
Saan ito kanina vlog siya?
Go, sir.
Yes, ilan to?
0.00244.
0.00.
2444.
4.
44. 37.
Yes. It's going to be actually. Okay, and then let's solve for AS.
Robby,
Is
sir.
equal to rho BD.
Wow.
0.002444
Times 1,000.
times ang
Times
This one.
150, sir.
Pila si AS.
366.
366.65
0.6568.
mm squared. Okay, this is expressed in terms of mm also. Okay, but wala siya kinabutang. This is in terms of 1 meter strip per meter. So that is using method 1. So for those na wala na sa method 1, method 2 ta. May lawa mo ni. Using principles. Yan ang principle ka ni. Ito ba ni pa?
Ito pa?
Mu over P is equal to
MM.
Mn. And ang ato na Mn is also equal to 0.85 F prime C AB D minus A over 2. So, principle na yan. So, 20, 191, 592.79 over 0.9 is equal to
Pila ito pa?
Walmart na.
Ah, wala.
solving for A yan. Pila si A.
Stay over 2.
Pila?
Oo. Hindi lang, sir.
Practicing.
8.627.
8.627
219.
219
883.
883.
3.
Star 8. Anong second equilibrium natin?
Ang
But C is equal to B. So 0.85 F prime C AB is equal to AS Y. So 0.85 F prime C 21. ACA is na-store sa 8. 8 times ang ating mag B na 1 meter strip or 1,000 mm. We can now solve for our AS. That is pila si AS? 366.
3668.
0.6568. O, pag gusto ka mo, kung ano ka method, kay same principle lang na ang inyong RM ka grow, they are derived from this equation. Kaya ang atom na equilibrium. Wait. Okay?
Saan natin?
Ano gusto niyo?
Siya, Japon eh.
Okay, so this is greater than or less than? Ilang AS min na natin? That is 315.
315, sir.
It's greater than AS min.
Therefore, okay. Sa naga lang man.
Okay.
Gab, sa naga, gab.
May AS
Sa
na tayo.
naga, sa naga.
Okay, so let's now solve for our S. Okay, our inward spacing
Asmin.
or theoretical spacing. So S is equal to 1,000 EB
Over
over
here.
ES.
79, sir.
AS is 366. 6568. Okay lang spacing. Yes, correct lang, no?
To, base sa laki, sir. So, pag sa pa.
215.
215.
46. Okay, theoretically, amo ning kinahanglan ng spacing, but we need to check ang aton na maximum. Is max.
One way slab, sir. Two way slab. One.
Okay, section 408.7.2 for two-way slabs. Okay, so this article.
Hulong. Hulong.
This
Shit,
article
belly.
actually reinforcement spacing. Okay, so for a non-phase stress na solid slab, a maximum spacing S of the form, a longitudinal or beam bar natin shall be the lesser of 2H or 450. Ila-inay sa one way, Anong common nila? Same sa one way na to, ng ila ng AS beam, same lang. Okay, same provision. But for our S max, okay, for our main reinforcement, okay, so that should be the lesser of 2H cap 450. Diba sa atin yung one way is that is 3H, no? Ang 450. Is H 2 times 175 ilan eh? 350. Ang isa lang eh? 4. Okay, ang 3 on na.
Siya.
S max is equal to 350 mm. Okay? And this is greater than sa ating na spacing. So therefore, okay. Sir, nga wala ka sa check sa S-beam. Never na-convert ang minimum spacing for your slab. Okay, unless ang loads mo na lagkogin or lagpad ang iyong mga span. Okay, so keep track lang ito. Ang practical checking is only the maximum spacing.
Dapat ako, sir.
Therefore, ang atong na final na design spacing, or sorry, our reward spacing, that is 215.46 mm. Okay, that ang atong na design spacing, okay, we will round off, depende sa inyo, no, kung anong inyong i-state inyong methodology, kung 25 mm tamo or 50 mm increment. But for our computation, okay, we will use 25 mm na increment. Na 25 mm. Okay, mas suppose mag-isip in terms of 25 mm kay nearest 1 inch. Usually, mga workers, they are using ng inches sa ilang mga measurements. So, nearest 25 mm is 200 mm. Okay, this is the design spacing sa bottom bars. Okay, along short span. Isa pa lang na.
Damo ko ba?
Or
Sakit, sakit.
first reinforcement. Okay, along short span. Ang question ko, ano ba plus stars din eh? Paamuni or paamuni?
Ang long
Plus stars na 200 mm natin. Paamuni?
Ano?
na.
Or tigda or patindog?
Tindog.
Patindog. Gusto nyo ito lang.
Tap.
Ha? Sino? Sino ka? Thank you.
Okay, so yung spacing is 200 mm. Okay, goods. Okay na? Next, top bars naman ta.
Ah, dali lang.
Diyan pa rin, di rap.
Kailan sir?
Top bar sa mata. Okay, top bars at Yota, bending along short span na line. Okay, top bars at the continuous edge or continuous side. Kung ganito nga term, side.
Kaya ba tatapos?
Panel A ka lang.
Sir, kung bilang CB, sir, ano ba ng spacing?
Tapos tumbay?
Kung pila ka CB, pila ka
Yes. Kung pila ka CB, ang unang inyo ang number of spacing. Pila ka bilog? Isa, dua, tatlo. Tatlo lang. Times 2, dua ka bending. So ano?
Ano, sir? Sa kada panel?
Okay, so let's solve for your factored uniform load. Okay, that is 1.2 uniform depth lang ang tina.
Ano, sir?
Ano ba? Alam mo sa kapil, 5 point pila na?
5.9125.
9125. Okay, plus 1.6. Pilang line? 4.8. No? Pila na ito?
Bilang siya. 14.775.
14.775.
775.
Okay, so let's compute for your negative moment, okay, along short span, okay, at your continuous side. Okay, so this is equal to your negative C A. Okay, multiplied by our factored uniform load times ang atom na L. Sir, nag-combine yun din. Okay, for our negative moment, okay, we don't need to distinguish ang ilang coefficient between delta and light load. Bilang aton nga negative moment coefficient?
0.069, sir.
0.069
Times
14.775. Bilang short span na net?
5.7, sir.
5.7. Bilang muwa?
Mama.
33.1227
122
4275
4275.
negative.
Ano yan?
Okay, moment dual na kuha pa dasit. Okay, so let's compute for your RN. Okay, that is 33.12274279.
Ay, naka-KN.
Ay, sorry. Plus RN 0.8.
Pulo.
Lapa 1.
1.63 635691
A store to F kay RN sounds like
F.
solving for your row.
Tapos may gamit ito.
Kapila na 0.00
0.0041
41
051
051.
5627 Pila?
Parang ba eh?
Kapilang ES
615
6
615 615.77 3434.
So this is m squared per meter. Okay? And this is greater than sa ESB natin. Greater than okay. So solving for our spacing. 1,000 times 17 over 615.77. Ilan eh?
128.
128.29394. Ilan?
294.
Okay, now check S-max. Ang question ko, ang S-max malain, if ever ang sinyo support, say nga dyan ko na, wala ka change ng provision for your S-max. Kasi dali, ang iya lang din na basis is ang inyo nga twice the total depth ninyo kung ang inyo nga 450. So regardless if bending along short or bending along long span, or if the moment is positive or negative, same lang ang aton na S-max. Okay, so therefore, S-max is still equal to 350 mm. Okay, all throughout na short span, long span, positive moment at negative moment. Okay, and ang aton na S-max is greater than sa aton nga computed. Okay, so therefore, aton na S required. Okay, that is 128.29 mm. Okay, and our design spacing for bending along short span at the continuous edge or continuous side, ilan siya? This is 125 mm. Okay, so this is for top bars. Okay, this is along short span. May-emphasize ko diyan, may confusion din sa mga plans. A long short span, okay, for our continuous. Okay. Okay. Ang atong na spacing for top bars, a long short span, at continuous edge is 1 to 5. Galing area, confusion din. Okay, so we all know our bending along short span, diba dali siya? Okay, so atong na top bars, din ang atong na continuous edge dali. Diba ari is continuous edge. So atong na 125 mm, dito siya i-distribute. Pero diin mo i-distribute yung top bars along din. Along long span, diba? Oh, there are some designers, sa ilang terminology, if you will distribute your support bars or your top bars, if you will say a long span, okay, is hindi siya ina-reference kung di ng bending, kung diin mo siya gin-distribute. Okay, so aton niya, gamiton ta for uniformity, para inumunta lang, okay, a long short span, all main reinforcement, negative moment or positive moment, that is along the bending sa short span. Okay, so when we say 125 mm, a long short span, okay, ang ato nina-refer is the top bar reinforcement for the bending along short span, even though in-distribute na siya along sa aton na long span. Nakasampok na mga pilay nila. Along short, kag along long. Diba? Okay, this is the top bars, okay, for the bending along short span at the continuous edge. So ang aton na distribution is siya. Kung 125 mas nipis, ino? Okay, so that is distributed all throughout. Okay, so this is 125 mm. Okay, at the continuous edge. May isa pa ta? Anong bilhin? This is continuous edge. Okay, erase mo na.
Sir, dali mo. Dot. Kanagon mo. Ayos. Thanks, boss.
This continuous edge. Okay, same siya po na. Okay, natin na factor uniform load is 14.775. Kaso, since this is a discontinuous edge, ang ato na coefficient for our moment is, ano?
0.
This is 0. Okay, sa liwat, ang assumption ni ACI, ang ato na discontinuous edge is a pin or roller support. Okay, so we won't have any moment for this computation.
Wala space.
Ari na. Space. So, MWA is
Zero.
0.
Wala kang
Hindi ka mo sa imo.
Okay, ang ato na RL is, ano? 0, 1. Ang rota is 0. Ang score,
Wala, tama ka na, sir.
AS is equal to 0 mm.
AS
Ang question, may spacing or wala?
Mayara, sir.
May yara ka sa
AS
min. So this is less than sa itong AS min.
Therefore, use AS
Therefore, use
AS
AS min. So AS natin is equal to 315 mm squared. So, per meter, kailangan dapat ito kami na. So S is equal to 1,079 over 350. Pila na eh?
50.79.
Okay. Take note that same job on aton na maximum spacing regardless if bending along short span, bending along long span, positive or negative moment. Kailangan maximum spacing that is 350. Ang import na is 250.79. So that is greater than sa aton na 250. So we will use a required spacing of 250.79 mm. And for our design spacing, any less than 5 mm, that is 250 mm on center. Okay? This is your design spacing. Ano na siya? For top bars.
Continuous.
Okay? Anong term lang eh? A long short span. This continuous edge or this continuous side. So gamitin natin is 250. Medyo nagka, no? Okay, if this is 200, dapat mas nagka siya. Ilang spacing sa din? Is 250 mm OC. Of course. Okay? Okay na. Okay na ato na reinforcement along short span. So next.
Then, pag-uwi ko na siya, sir. 11:30 na, sir. 30 minutes.
Tapos ang dalang. Lunch na lang. Long span na ta, dasing na lang yan.
Sir, kung gusto nyo na sir, kung alam mo short, medium. Alam mo, sir.
Kamatay pag-insure pa sa last part.
Sir, daw ginahan.
Part 2, bending along long.
Long.
Same job ng ASB na. Okay, that is 315. But, ano ang deeper din eh? Alam ta? Mamatikan na eh. Okay, since this is bending along long span, okay, ang aton ng effective depth is malait. Okay, sa liwat na, ang aton na main bars for long span is located above your short span. Okay, for your positive moment, okay, for your negative moment below your short span. So, paano suma sa aton na B for a long span? So this is H minus ang clear cover minus 1.5 your bar diameter. Kasi liwat, ang ating na long span reinforcement is located above your short span reinforcement. So 175 less 20.
Hindi, kayo ano mo?
Bilang atom na effective depth?
Tama.
Yes. 1, 4, 5. Cut and then, hindi.
1.5 sir, di
Hindi
ba?
na lang 1.5 sir.
1.5 lang yun.
140.
Hindi ba, this is your clear cover. Tapos, this is 1 bar diameter. Ang inyong effective depth for your bending along long span, agi siya sa babaw. Okay, sumiyaka mo sa 1/2 bar diameter. Same sa footing, wala. 140 or 140? 140. Sure?
Sure sir.
Promise?
Promise.
Okay, AS min, same Japon. Okay, kung wala ka change ang aton nga section property. Balik naman ta, bottom bars naman. Bottom bars.
Ang AS min is sir nila ba?
O same. Hindi mag-change yung AS min, kasi bang iya ka property, reliant sa inyo nga FY, ang inyo nga AG. AG siya. Basta nag-change ang inyo nga effective depth, okay, sa bending along long span, si AG is still the same. Okay, that's why same Japon si AS min.
Oh.
For our bottom bars,
Gawin ang bars
that is MU,
sa
1.2, positive CB dead, plus uniform dead, LB squared, plus 1.6 positive CB line, uniform line. Ilang CB dead ganit? 0.0172. Uniform dead,
5.9125.
5.9125. LD, 6.95. CB live, 0.0215. Positive MUB. Ilan eh?
Thirteen. 13.758.
13 point
758.
758
9671.
96
713.
7138 13. Computing for RN. So, ang di nag-change siya is 140. Ilang beta?
Danay lang sir. RN lang sir.
Take your time.
0.77.
Is 0.77.
9986.
9986 7988.
7985.
Ha?
Store this to M.
7.
Pilang rota?
Dali lang sir.
Kaya kabilog sa luwag top bars, tapos temperature bars.
Point 0018.
0,
1899.
99.
5625.
0.001899 times 1,000 times 140. Bilang AS na?
Dali lang, sir.
265.94.
265.94.
94.
Okay. That is less than or greater than?
Less than.
So this is less than sa itong na AS min.
Therefore, use
Therefore, we will use AS min. For our AS required.
Same lang sa
Same lang, sir.
Same lang.
Oo, sir.
Okay. 265.94.
1,000.
So 1,000 times 79 over 265.94. Tani ka ni?
Ha? 315 ko na sir.
315 puro, sir. Ay, less than 1.
Less than 8.
Same lang ang 250.
Oo, sir. 79.
Ang question ko, ang S-Max ma-change hindi. Same job ang S-Max, hindi bang iyang ang properties nila yan sa thickness kan sa 450 ang yan. Okay, so maximum spacing is 350, ang required spacing is 250.79 mm. Okay, therefore, S required is 250.79. And ang atong design spacing for, example lang, this is for bottom bars. Okay, along long span. Okay, so 250 ang ating na main bars. Mas lang ka siya, no? Parallel to long span.
Okay.
This is 250 and
Oops.
Kata lang kita. Top bars.
Duda, sige mo, sir.
Undo.
Ando.
Reverse yan, reverse.
Grab, grab. Grab. Grab.
Lalapit ko lang.
Okay, top bars for continuous S. Ganong factor yung form load sa nilina?
Ay, ang tanan.
Kaya ina.
14 na naman.
Ang yung user?
Ay, ang factor yung
14.775.
14.775.
Ako continuous edger, pwede ka combine. Ang gusto continuous na hindi.
Negative movement, pwede na combine. Negative. AMU at short span. Okay, so that is negative CB. That would be
6.95, sir.
ilan eh?
Bila to?
22.123.
1K?
22.12375. 256. Okay. 1, 2, 3, 1, 2, 3.
Plus RN.
254,
1.254,
181, 180, 984,
store this at ilang rota? 0.099.
003, 099,
AS. Ilan?
433,
433.879.
433.87,
8. Oh, and this is greater than sa ating ASN. Therefore, okay siya. Oh, stay safe din. Sige. 10 minutes, 10 minutes. Muling pili na, oh. 5 minutes left. Nalabas na!
Box yung final answer.
Aplan eh.
Dali lang, sir.
182.08,
122.82.
82. Hindi, 182.08.
Wala tao. 182.08. Oh, same siya pag ang S-Max ha. Favor in ang S-Max is 350. Ang required spacing is 182.08. Therefore, our S required is 182.08. Okay, so design spacing is 175 and 1 centimeter. Okay, this is for top bars. Okay, along long span. Okay, this continuous. Okay, 175 at the continuous edge.
Open up.
Okay, this is 175.
And then, of course.
Oh, last. Hindi, last two ulit. Go! Okay.
Last na, last.
This continuous edge.
0, sir.
10 minutes up. Lewat na. Okay, so for our discontinuous edge, our coefficient is 0. The movement times is equal to 0. Zero means 0. Rho is equal to 0. ES 0. Okay, and this is less than AS min.
Therefore,
Use AS min. Okay, so AS is equal to
315.
1.
250, sir.
Dami na hens, 250.79.
79.
Kasi ito dibagi na. So since the maximum is 350, okay, so this is equal to 250.79 mm required spacing. For our design spacing, this is equal to 50 mm on center for top bars along long span. Okay, at the discontinuous side or discontinuous nice. Mas lagka, no? 250.
Okay, since they don't have transverse reinforcement. Maria, for bottom bars bending along long span, kaya niyara ka sa short span ng reinforcement to provide us transverse or temperature reinforcement. Okay, unlike sa support, ang ating na main bars wala sa transverse. So we need to provide our temperature or shrinkage reinforcement. Last for our part 3. Okay, so for our temperature reinforcement, I need to go to section 424, that is for serviceability.
Page 1, sir.
Okay, so these are all questions from for our temperature reinforcement. So we'll use the table 4.4.3.2. Okay, so these are all minimum still ratios for our shrinkage or temperature reinforcement. Okay, so since ang atong transverse reinforcement is also formed by the PA, okay, so we will select the greater for the following. Actually, same na diba? Times 420 over that's y. Isa is 0.001. Okay, so we'll use the 0.001. Okay, so for our transverse reinforcement or temperature reinforcement, 0.0018. Okay, multiplied by the area of gross section.
Gross.
Okay, so this is 175 times 1,000. Kailan eh?
3,1,000.
3,1,500 mm. Same, no? Ari. So for our temperature na spacing, okay, this is equal to 1,000 times 79 over 315. Okay, that is 250.79 mm. Okay. So our design spacing, okay, for temperature reinforcement, okay, so these are your temperature reinforcements. Okay. Okay, isa lang na. Okay, for our ito wala na. One section din. Okay, complete ng spacing, but how can you make it more presentable? Okay, para masapos siya i-implement on site. Okay, so I'll take lang example na po before we end. Instead na naman ng PDS plus 5.
Pero kasi andyan na lang sa dito. Araw sa AST sa AST sa 125.
Thickness ng slab na gross area.
Di ba Robbie din?
Hindi. Ang ating na sa picture is gross. Each.
Ay,
imbis na BH.
Nag-try na to. Ito. Uy.
Sir, ikaw nag-design, sir?
Okay, before we end, di para mas ma-appreciate ninyo, two ways lang.
Pwede mo na kuha, sir. Ikaw lang yung nag-design. Ikaw nag-design, sir.
So we have here our panels.
Hindi kita taon, sir. Ayan.
Tapos sa third,
Ikaw lang yung nag-design.
usually, you will, hindi ko define yung mga panels, they bounded by your pins, and i-label siya. Okay, di ba tayo importante i-label? Okay, so wala na label.
Medyo pa, so
So we have here S1, PSK, I think wala din S2. Independent na if paano siya design. So basically, you will have three design for mga
sir.
We're in, pinaklan ninyo, you need to provide schedule for slabs.
Ano, sir?
Ay, schedule for slabs. S1, S2, S3. Okay, dali mo siya identify if one-way siya or two-way. Based on this design, S1 is a one-way slab. S2 and S3 is a two-way slab design. Okay, so let's focus on the two-way slab. For our two-way slabs, we'll have two bending. Okay, we'll have a long short span and a long span. Okay, then a long short span, may tatlong kategory. Try to check. Okay, a long short span, straight bottom bars, a long short span. Okay, top bars at the discontinuous edge or discontinuous side, and top bars at your continuous edge. O same kanina, diba a long short span, we will have three spacings. So may spacing sa bottom bars, may spacing sa top bars at the discontinuous side, spacing sa top bars at the continuous side. That is a long short span. Okay, namin ang spacing. Using na ng at 150 at 225 at 110. O try to observe lang. Hindi na mas dako mas spacing. Discontinuous or continuous? Yung mas dako ang discontinuous. So mas dako mas ikikit ang sa continuous edge. Try to compare sa aton. Okay, short span na. How the short span? Discontinuous na top bar is 250. Okay, continuous na top bar is 125 mm. Uy, no? May compare ito. 110, kaling aton niya is 250. Ira 225. Well, dito naman 225. Okay, then for top span, alika. Straight bottom bars, okay, long span. Top bars, continuous edge. Top bars, continuous edge. Third question, hindi masunod ang temperature bars. Okay na. Hindi masunod ang temperature bars. So this is our typical plan. Okay, ito sa two-way slab plan. So if you want spacing at your span, okay, ari siya continuous. So this is counted between L over 4. Okay, sorry. Ang ating top bars will end at L over 4. This is L over 4. Pero ang bottom bars na shall be extended up to L over 5. And plus start with the bottom bars na even though dali na siya needed with this extension, they have to extend up to your support. Okay, stay today.
Look.
Wala, ano na?
Ano mong sabi sa bilan? Okay, cover sa. Last na. This is your bottom bars. Okay? for bending along short span. Okay, muna sila. Okay, so for practice, alternate bars sa bottom bar shall be extended up to the support. Okay, so alternate siya. And amo siyang inyong spacing sa bottom bar. Okay, alternately, in-extend siya going to your support. Okay, and this distance, okay, this is equal to L over 5. Okay, pero ang top bars niya, as na lang sa end. Okay, top bars should be located only at L over 4. Siyempre, based sa atom na pag-intending, ang atom na negative moment na-terminate at L over 4. Okay, so dali lang as the atom na negative bar. But for our bottom bar, in order to provide enough development length, okay, ang difference nila. Okay, because we will introduce development length by finance. We all know that L over 4, okay, diba dali over ang negative moment, what is here, positive moment. So, inyong ang bottom bar, kinakailan niya i-extend. Okay, even though dali siya nakat at L over 4, pero i-extend siya by this amount. Diba ta? Si positive moment, dali lang dapat as na kinanglan. Okay, from our figure, okay, dali siya na-terminate at L over 4. Pero ang question, na-extend siya. Beyond sa ating L over 4. Okay, this is introduction na ito na last topic for finance. Actually, this is your development length. Okay, and like sa inyo yung top bars, okay, really, binaharap mo yung development length. Ari yung development length. So, what do we mean by development length? Okay, aside na na-design lang sa inyo ng main bar, kinanglan, naka-embed ang inyong mga kapilya para mamersa siya by FY. Okay, may duwa possible failure ninyo. Either una, mag-weigh ng material na mag-yield siya, or mauna huslo ang kapilya. Okay, so we need to provide enough embedment para kung tutungon yan through tension forces, hindi siya mauna huslo. Malagpot ng iya yield strength. Same with our bottom bars, iba din siya mamersa. So tutungon siya may tension force na din. Okay, this is your tension. Sa ating plan, equilibrium station, ito may C tag T. Okay, ang hindi siya na T, so dapat may enough ng investment, kung mamersang inyong span, hindi mauna huslo ang inyong okay, so we will discuss development length by final. Okay, in details, na L over 4, na L over 5. Okay, and take note, these are your temperature reinforcements. Okay, so dapat, sa yung final design, in this spacing dapat may summary ka mo. You need to determine pila ang unique slab schedule. O let's say napili ka, may kamuan ng panel, S1, S2, S3, S4, S5. O let's say this is S2, this is S3. Initially, may S4 to S5. Kasi yung problem, sa inyong S4, this is 10 and also at 150. In 10, diameter at 250, this is 10 mm diameter at 125. Okay? So, inyong S4 is almost the same with your S2. So, pwede mo siya mubra, instead of having 150, kasi mo siya na 150 along short span. Tapos ang inyong top bars at is continuous L, ang inyong S4 is 250, mas lapit sa S2, so ito sa 225. Hindi ba mas conservative, is mas ikit yung spacing. Then last, for your top bars sa continuous L, ang inyong design is 125, pero ang inyong S4 is 110, pwede mo isahon ang S4 at S2. So when kailangan magambal na unit ang inyong span. For example, S3, ang iyang spacing sa along short span is 130. So hindi pwede yan, napalihos na mo nito. Okay, mas akong savings in terms of number of reinforcement rate, 230 is 225. Wala talaga 110, mainay nila nga per span. Depende dyan kung sa inyo if i-push through nyo nga 5 ka-schedule or you can simplify it up to 2 or up to 3. Okay, so wala sa rule of thumb or hard rule na magambal na sir bilang minimum na slab schedule. Depende dyan kung sa inyo. Kung gusto nyo, let's say, 20 kabilog na span, o S1, S2, S3, S20, kung gusto ka mo, hindi ba na nakisahon na mo nga 20 kabilog inyo na slab schedule. May laki kaayawan ng workers pangita. Ito S14 din ba? 12, 30, S14. Okay? So this is designed for two-way slab. Any questions?